Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh, and good day everyone. My name is Nasr Mazal Muhammad. I'm from Group 4. Today we like to present about SEAA 2012 G4-3 point load test. Our lecturer is Dr. Afika binti Rahim. Here are our group members: Chu Zingying, Amira Dalila binti Jamaluddin, Tong Ren Hao, Muhammad Nazri bin Muhammad Nasir, and lastly me, Nasrul Nazam bin Muhammad. Next, I'm going to explain about the introduction about point load test. In order to establish the point load strength index IS50 and unconfirmed compressive strength, core rock specimens or irregular rock fragments are subjected to a point load test. This test does not involve the preparation of an inspecific specimen and is quick and simple. By measuring the failure load P and the distance between platens D, the uncorrected point load strength P over D2 may be determined. The unconfirmed compressive strength is determined by using a correlation equation after specimen size and shape adjustment have been made. Depending on the specimen geometry, three types of testing may be conducted: diametral, axial, and irregular lump. ISRM suggests testing strategies.
Hi to Dr. Africa, I'm Chu Zingying, and now I'm going to present the objective of G4-3 experiment, which is to obtain the compressive strength of rock specimens using irregular lump tests. Next, which is a theory, which is the point load strength test is used to forecast the uniaxial compressive strength, and it is increasingly replacing the uniaxial compressive strength test as it is reliable and faster. IS50 should be utilized directly for the rock categorization as it is simply approximations. Generally, uniaxial compressive strength is 20 to 25 times of the point load test. And the ratio can range between 15 to 50 for various rock types, and especially for anistrophic rocks, and inaccuracies of results can up to 100% if the arbitrary ratio is applied. Lastly, point load test is an indirect tensor test, and IS50 is around 0.8 times the uniaxial or Brazilian tensor test. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Dalila binti Jamaluddin. So for this experiment, I will explaining the procedure. So the first one is the dimensions of sample rock was measured. Second, the upper width and lower width of the sample rock were measured. Third, sample rock was mounted by a point load tester between the two pointed platens. Four, the digital indicator was initialized once the sample rock was held in place by the two pointed platens. 5. The initial reading on meter rule mounted on the point tester is also observed. 6. Force was exerted continuously on the sample rock by pumping the point load tester until the sample rock breaks. 7. The readings on the digital indicator was observed. Lastly, repeat all the steps with the other sample rocks. That's all for the procedure. Later on, I will continue with the demo for this experiment.
Okay, so firstly we will take a sample of a rock and then we will measure the dimension, which is the upper width and the lower width of the sample. Okay, next we will take the rock sample and put it between the two pointed platens. And then we will apply force, which is load, and when the sample rock breaks, we will take the failure load. That's all for me.
For the data analysis, we use three number of sample. From the experiment, we get the data W1, W2, D, and load. And from that data, we calculate the cross-section area A, equivalent core diameter D squared, size correction factor F, uncorrected point strength IS, point load strength IS50, and lastly we calculate UCS. So for the calculation, we use test number 1 for the sample as a sample. For number 1, we calculate the W average with formula W1 plus W2 divided by 2. We get the 31.99 millimeter, and then we calculate the cross-section area, W average multiplied by diameter. We get 787.59 millimeter squared, and then we calculate the dE squared equal to 4a divided by pi. We get 1002.79, and then we calculate the correction factor with formula dE over 50 with the power of 0.45, and we get the value 0.8142, and then we calculate the point load with formula P divided by D squared, uncorrected, we get the 7.9777 megapascal, and then we calculate the corrected point load with formula IS multiplied by F, we get the 6.4954 megapascal, and lastly we calculate the UCS value with formula 24 multiplied by point load 50, we get 155.8896 megapascal. For discussion, based on this experiment, the higher the value of unanswered compressive strength, the higher the strength of rock. From data, 3 samples of rock has been used to determine the unanswered compressive strength. The cross-section is considered as trapezoidal shape, with its top and bottom bases W1 and W2 being parallel and its height being constant. The average value of W obtained by using the value W1 and W2. The value UCS can be calculated using a formula after the point load has been corrected. The highest point load strength is from sample 1 with a value 6.4954 megapascal. The lowest one comes from sample 3 with a value 3.9340 megapascal. Sample 1 has the highest value because it has a smallest cross-section area than sample 2 and sample 3. From the IS50, the UCS value can be determined, which is UCS equal to 155.8896 megapascal from sample 1.
Good morning, Doctor. My name is Tong Ren Hao, and today I'll be talking about the conclusion. So the point load and compressive strength, also known as UCS, was obtained throughout the experiment. Therefore, it can be concluded that rock sample 1 is the strongest since it has the highest value of point load and UCS value, whereas the weakest among the 3 rock samples is rock sample 3, with the lowest point load and also the lowest UCS value. That's all from me. Thank you very much.